Ugh.
Okay, can you hear me? Can you hear me, your mind? Okay, great. Thank you, Alexandra. Grace? Okay. Okay, howdy. Great. So today, before starting the lecture, I will give you two announcements and one correction. So first announcement is that exam one review is today. What I mean is that if you have find any difficulty on your exam scores, some if you think that you are right in the problem, but I graded wrong or something else, then please let me know that you can always claim to me about your grade, and I definitely help you to review your scores. So that's the today. And some students actually ask what the solution of the exam 1, and I will post it after all. Actually, there are some students who need to take the makeup exam. So therefore, I didn't post the solution right now, but I'll post it after all students take the makeup exam 1, then I'll post it the solution in the eCampus. So just, yeah, wait a little bit about a minute. But if you still have a question about the answer of the problem in the exam 1, then you can just ask me using email or Zoom, right? Okay, then I will let you know. And again, we will have quiz on this Thursday. And this quiz contains the matter chap from 5.1 to 5.7, which we will deal with today. So, and it will be on the website. And as usual, you can just serve the, like other homework in the website, you can just serve the quiz on the Thursday, right? So these are two announcements. Okay, do you have any question on this or anything else? Okay. Review, actually, oh yeah, so just give me an email on, I will take any claim before the midnight. So then I will, yeah, respond it to you, yeah. Okay, so midnight, okay. Great. And any other question? Good. And there is your one correction. Thank you very much, Dawson. From Dawson, I know what I had missed. So to explain this mistake, I just asked some basic question. So thinking about the example of building a fence, and you can see that to build a fence, first of all, you need to put some, vertical stick on there, and you need to put some, yeah. Oh, sorry, what it is. Okay. Put it in here. So we can see that this is a fence, and you can just connect them bunch of these fence to make a line between some region, right? So I have 3 block of fence, also fences. Then how many sticks I use for building 3 block of fences? 4, right? So it needs 4 sticks to build 3 blocks of fence. And what I had mistake is the example 1.5 when I say something about the size of class. So in the previous note, I just say that size of class is 5, but what I wrote down is 51 to 56 and 57 to 62 and so on, right? So if you just see this example, then what we have is 51 to 53, 54, 55, and 56, right? So there are 6 elements can be inside of this interval, right? So in this case, actually what we have is size 6 because size is determined by the number of elements, number of types which you can add in the interval, right? So but I just wrongly think that since their difference between 551 to 56 is 5, so like a case of fence, so I think that this is the size 5, right? But that's wrong. So in that case, the correct one is if you have crest with size 5, then your first interval should be 51 to 55, right? Because it already contains 51, 52, 53, 54, and 55. And next one is 56 to 60. And so also it requires 56, 57, 58, 59, and 60, right? So these are the size of 5. So the previous one should, if you want to preserve the previous nodes, then just change your size as 6, right? Then everything is okay. And likewise, I said that in the below histogram, the crest size is 10 in the previous node, but actually this has size of 11 because, by the same region, from 51 to 61 contains 11 number, right? Including 61, right? So that's what I had a mistake. So I just, corrected in directional, but I'm so sorry for this mistake happen. I don't know why I had a lot of mistake in the raw structure, but I hope that today I will do not make any mistakes. So, okay, so that's what I want to say about the correction of the notes. And thank you, Dawson, for letting me know. Okay. Do you have any question? Okay, great. All right. I actually missed the one announcement. So at this time, this quiz score will be counted as your exam score. Especially exam 1 score. So it has so in this exam 1, the average, which we will deal with today, of your exam 1 is 69 or 70. So I think that I hope that you guys get the 75 for the average, but it's not that high. So I will give you some bonus keys on this week. So if you just if you get the full credit on this Thursday quiz, then your exam score will be up by 5 points, right? Okay, so that's my bonus. Is everyone? No problem. Yeah. What is the quiz going to be over? Quiz gonna be over about the matter in from 5.1 to 5.7. Yeah, and from 5.4 to 5.7, we will deal with today. Okay. Okay. Do you have any question? Okay, great. Then let's deal with there is some question. So Dawson says that so it will go towards our exam 1 grade? Yes. So your exam 1, that the quiz counted as your exam 1 additional grade, right? Additional score. And Jackery says that so will it just be bonus points? Yes, it's for bonus point. But you need to prepare the materials you learn from this chapter 5. So no, it is just bonus points. So full credit, it is actually counted as 100. But if you get the full credit on the exam 1 and this quiz, then you got 105, and still you earn 5 points more. Yes, so this upcoming quiz is over last lecture and today's lecture. Yes. Okay, thank you. Okay, do you have any other question? Okay, great. Then let's start the 5.4. So when we say about the average, it is just, average of some data. So, but there are 3 different meaning on average in the statistics. The first one is called mean, and we always represent our data as x1, x2, blah, 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 xn. So these are our data. And our mean is denoted by x bar, is a set of the observations on the representation of center of distribution. So what it means is that just sum of all your data divided by the number of your data, right? So sum of data divided by number of data, right? So this is, intuitive concept, right? So this is called mean, and that's the first definition of average. And second one for average is called median. And median is just some number which is in the middle of your data, right? So for example, a median is represented by large M. And if you have an N data, and if N is odd, then median is X and N plus 1 over 2. So what it means that, for example, if you have a data X1, X2, X3, X4, and X5, and these data are actually assume that these data are ordered from ascending order. So X1 is less than X2, and X2 is less than X3, X3 is less than X4, and X4 is less than X5, then your median is the middle number, right? In case of you have the odd number of data. So for example, if you have your data 1, 3, 7, 9, 11, then your median is 7, right? Or if you have data 126, 347, 910, 1000, then still your median is 357, right? So it is just middle of your data, right? If n is odd. But if n is even, then it is actually mean of the two data which are in the middle and the next one. So again, if you see the example, then it is clear. So if you have 6 data, 1, 3, 7, 9, 11, 13, then actually our middle should be here, right? So this one or this one should be our middle, but if we just choose this 7, then it is a little bit slightly skewed in the left, but if we choose the 9, then it is slightly partial to the right. So what we did is just take a mean of these two numbers, right? So in that case, 7 plus 9 over 2 is just 8, right? So in that case, our M is 8. And likewise, we can use the example. And 1201. So if we still have the 6 data, then again, these 357 and 910 are in the middle, right? So in that case, just take a mean of these two numbers, which is 357 plus 910 over 2. And in that case, it is 2, 6, 3, 3.5. So 633.5 is your median of this data, right? So mean is just sum divided by number of data, but median is just the middle number if we just let them in ascending order, right? Okay. Do you have any question on mean and median? Okay. And next one is mode. And it is a little bit different with median and mean, right? So for example, mean and median has only one value, but mode is just set of observations that occur most frequently, right? So you can have no mode, or if there's tie, then you can have multiple modes, right? So for example, our given data 1, 3, 7, 9, 10, there is no mode, right? Because every data just came at once, right? And again, in case of the next example with green number, it has also no mode, right? But if we add, instead of 13, maybe we can add 11, then in this case, you can see that actually this 11 happens twice in the 6 data, right? So in that case, our mode is 11. And moreover, maybe if the second data is not the 3, but is equal to 1, then it has 2 modes, which is 1 and 11, right? So compare with mean and median, mode, there is no mode, or there can be no mode, or there can be multiple modes, right? So it's a little bit different with the other concepts on average, mean and median, right? So, and all of these measurements will have the same unit as the data value, right? So usually your data value has some units, like a minute or distance or something like that. Then mean and median and mode also have the same unit, right? So let's deal with some example. So following just scores on the honors exam from a class of 17 students. And now I want to calculate the average score on the honors exam. It means that I want to calculate this mean, median, and mode, right? And to calculate mean is just sum of all of these numbers and divide by 17, right? And so some data and divide by 17 in this case. And if you just take the sum in these data, then what you can get is 1427. I just calculated in the, before the lecture to avoid the mistake on calculation. And if you just put it in your calculator, then what you can get is approximately it is 83.9, right? So that's your mean. And to get the median, we know that we need to figure out the middle of this 17. And in case this 17 is odd, so in this case, middle number should be 17 plus 1 over 2, which is 9, right? So you just pick the 9th element of this one. And thankfully, these data are already ascending order. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 87 is the middle number, right? So median is 87. Right? And lastly, to get the mode, you need to count the most frequently occurring number, right? So in here, if you see this, then only 17.7 occurs twice, and all other numbers are occurs just once. So in that case, mode is 77, right? Okay, do you have any question on this example? Is it good? So as you can see, all you need to be careful is just finding a mean, right? Because median and mode are, there are no such opportunity to miscalculation, but in case of mean, just be careful about the sum. And here, is there any obvious outlier? And if you see those data, then actually 32 seems like an outlier because all other numbers are in between 70 to 100, but 32 is too, it is too outside of those interval. So 32 seems that it's outlier. And remove the outlier and recalculate the mean and median and mode. And to recalculate the mean. Now, since we get rid of outlier, so our case it should be 16 students, right? So in that case, mean is the sum of data, which is 1427 minus 32 over 16, right? And this should be, I also calculate this one, 1395 over 16, which is approximately 87.2, right? And in case of the median, we get rid of this 32, right? So if we get rid of 32, then we had only 16 elements in the data. And we know that now 87 is not X9, but X8, right? Because it is 8th element from the left. And 89 is 9th element from the right. So median is just 87 plus 89 over 2 because there are only even number of data here. So in that case, it is 88, right? And in case of mode, still there is 77 is the only element which occurs twice, and the all other elements just occur once. So in this case, mode is still 77, right? Okay, do you have any question on this? Great, so by removing the outlier, you can see that, yeah, first of all, mean is increased, right? Because if we count outlier, then mean is increased from 83.9 to 87.2. So mean increased highly, and median increases just a little bit because it is from 87 to 88, but mode is stable, right? So this is not always the case, but it is the special case when your outlier is in the red, right? Which means that your outlier is less than mean, right? Or median. So if your outlier is not in 32, but if your outlier is just, for example, if you have a student with score 1000, then by removing that outlier, your mean and median decrease, right? So therefore, you can see that mode is the stable measure without the, it doesn't affect by the outlier, and usually, but mean and medians are affected by outlier, right? So, and we will see such an example next time. So about some other examples, right? So, okay, great. Do you have any question? Great. Okay, so let's do it next one. So what we run is mean and median and outlier. So it all measures the half of the data, right? Because average of data means that just half of the data. But now we want to deal with the 1/4 of the data and 3/4 of data. So if your data looks like this, then we just make some quartiles on your data. And to deal with this, we need some another notion in mathematics. So first of all, the range of your data is a measure variety. It just measure the boundary of your data, right? So for example, the smallest data on your point is like A, and the largest data is B. Then range is just B minus A, right? Because that's the, all other data are in the interval between B and A, right? So we say that the range of your data is B minus A, and we can just put into, 4 groups of the data, right? And these are called quartiles. To make 4 groups of data, we need 3 more sticks to put on your data, right? So it is called, so this 5 number is called actually 5 number. Okay. 5 number. Oh, sorry, it's not 5 number. Is, quartiles is a set of 3 observations, Q1, Q2, Q3, cutting data into 4 groups. And the max is the largest observation. So here is our max, which is just B in our example. And Q3 is the median of the data above the median, right? So Q2 is median of all data, and Q3 is just median between those, the data which is above the median. And Q1 is the median between data from A to Q2, right? So what we did is, actually, for example, say that we have some data from X1 to Xn, then just put it as a half and half, right? By taking median M. Then again, from the data, from the first half, you can get another median, right? And you, from the last half of data, you can get another median, right? And we just call it as a Q1, Q2, and Q3 for those medians, right? So these are called quartiles. And first quartile is actually the first 1/4 part of your data, and second quartile is the second 1/4 part of your data. And second quartile, and third one, and fourth one are, those data, right? Okay. Is one that's supposed to be Q3? Q3 is median of the data above the median M, so this should be Q3. So Q3 should be greater than Q2, and Q2 should be greater than Q1. Does it make sense, Destiny?
Professor.
Okay, got it.
Q3s.
Yes, you're right. Sorry,
Okay.
I had a typo. Right, yeah. Okay, so Q1 should be here. So Q1 is the median of the data below the median, right? Below Q2. Yes, sorry about that. I had a typo. And thank you for pointing out. Okay, and the last we say that the interquartile range or IQR is called is the number from Q3 to Q1, right? So it is kind of range between second and third quartiles of data, right? So sure. And right. And this IQR will be used to figure out the definition of outliers. So we will see in the following. But let's deal with first example. So these are the same 17 students from the last one. And we want to find all those information of this given data. So the minimum was 332 and maximum is definitely 100. So range is 100 minus 32, which is 68. And mean is, actually we already calculated mean, median, and mode. So you can just write down the previous example, mean 83.9, and median is 87, and mode is 77. Then now we need to find Q1, right? So to find Q1, we know that 87 is our median, right? So we want to find median of the first half of the data from 32 to 85. And this has already 8 data in here. So median is just mean of these 2 data in the middle, which is 77, right? So it is 77 plus 77 over 2, which is 77, right? And our Q2 is just nothing but median, so it is the same as 87 because our median is 87. And Q3 is median of this last half of the data. And here the middle number is 95 and 96. So their mean is just 95 plus 96 over 2, which is 95.945, right? And your IQR is 95.15 minus 77, which is 18.5. Okay, I will write down. Oh, sorry. Okay. Right. So those are some numbers called statistics. So the meaning of one of the meaning of statistics is just some number which shows your property of your given data, right? So here we know that minimum of your data is 32, maximum of your data is 100, and it is divided by 4 quartiles using 77, 87, and 90.5, and so on, right? So Porras says that when there is a decimal in the mean, do we round or we just leave it as is? So in the actual exam work quiz, I will just want you to write down the rational form, right? So, or or if I need some roundup, then I will make it a specific. I make a specific instruction on the exam, so don't worry too much about the roundup. Yeah. Okay. There is. Do you have any other question? Okay, so next example is about the daily high temperature in Kari Station, right? In March 26. Yeah, in 14 years ago, Kari Station is much more better than right now because I didn't have any such a great, temperature in March. March is always summer in my memory, but anyway. So let's find the following from the given data. So in this case, you need to be careful that now it is ordered by descending order, right? So the biggest one is from the left and the lowest one is from the right. So in that case, you need to be careful to deal with your quartiles and min and max. So first of all, your mean is 51, right? It's easy. And your max is 86. And range is 86 minus 51, which is 35. And to find mean, you need to add all those numbers. But yeah, if you just calculate the sum of your data, I pre-calculated it before the lecture, it should be 23, 12. So 2312. So your mean is just 2312 divided by how many data? Number of data is 31, sorry, 31. So your mean is 2312 over 31, and it is almost the same as 74.58. So I just write down as 74.58. And median is the middle one. And since we have the 31 data, so 31 plus 1 over 2 is 16. So we need to figure out the 16th data from the right, because right is the smallest one is in the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So median is 76, right? So here is our median. And to figure out the mode, actually you need to count all the numbers. And you can see that actually it is 69 and 72 and 77 occurs 3 times. And all other numbers occurs at most twice. So in this case, there are 3 modes, which is 69, 72, and 77, right? Then from the definition, Q2 is just not same as the median, so it is just 76. And now Q1 is the last half of the median of the last half, because last half contains the smaller data below than the median. So and this last half has how many data in there? 5, 10, 15. So it has 15 data. So again, 15 plus 1 over 2 is 8. So if you just pick the 8th data, then what you can get is 69. And to find Q3, again, it is the first half of the data. And by the same way, you can just pick the eighth data in the first half, which is 81. And IQR is 81 minus 69, which is 12, right? Okay. Do you have any question on this example? So what you need to be careful is that, first of all, when you see such a problem, then what you need to check is whether your data was ordered or not, right? So if it is ordered in ascending order or descending order, then you can just find directly your mean, max, or any statistics from the data. But if your data is not ordered, then first of all, you need to put the data in numerical order, right? Before calculating those things, right? Otherwise, it is a very, yeah, it is very easy to have a mistake, right? Okay. Do you have any question? Good. Then let's deal with example 5.4. Actually, it is the same as example about the outlier. So think about the median and mean and mode of the rest of students in this class. And assume that we have big H as our secret students, right? Then how big H affect on the mean and median and mode of the rest of students? So thinking about data one is just our students. I hope that I have no student. Big H is not my student, but and let's say data two is our students plus big H, right? Yeah. Then if you think about mean and median and mode, then definitely mean should be, I'll write down just. Mean should be greater here, right? Much more greater than data two has much more greater mean than data one because usually Big H has a lot of money than us, right? So if we just put Big H out of our data, then our mean dropped very closely. But the median is not that, yeah, maybe median is still the same or, yeah, but it is still a little bit bigger than the original one, but yeah, median does not affect such a thing whether Big H is our student or not because, Big H cannot be a median, right? And median students are actually similar for each other. So usually median is not affected well. And in case of mode, usually mode is just stable, right? So since we assume that Big H is the number one richer in the United States, so definitely there is no more person who has the same wealth with Big H. So definitely Big H is not the mode. So it doesn't affect how frequently the data occurs. So therefore mode is the same, right? So, and that's why we wanna get rid of outliers in our data because usually, yeah, mean is affected very well by the outlier. But if you just, yeah, put outliers, just remove outliers from the data, then you can get the more accurate information about your average, right? Okay. Do you have any question on these examples? Great. Now we are dealing with the 5 numbers test summary and box plot. So we know that actually these quartiles have these 5 number, right? Max, Q3, Q2, Q1, and mean. And these 5 numbers are called just 5 number summary of distribution. So it gives us the what is the 1 pulse and 2 pulse and 3 pulse and max and mean, right? And box plot is just graphical representation of this 5 number summary, right? So to draw a box plot, first of all, you need to figure out what the mean and max and draw Q1, Q3, Q2 in your number line. Then put box on your second quartile and third quartile, right? So it is just nothing but the visual representation of this 5 number. So let's deal with the box plot for previous example. So in the previous example, we know that mean and max is one. First of all, you can put your mean is, where is, yeah. Okay, they use this data, mean is 32, and your max is 100, and Q1 is 77, Q2 is 87, and Q3 is 95.5, right? So to draw box plot, first of all, you can draw your number line here from 32 to 100. And then 73 is actually, it is a little bit close to the 100, and 83 in here, and 95.5 is near the 100. So your box plot looks like this, right? So that is box plot for your exam score. And from box plot, you can see that actually the three first quartiles are skewed in the right? So all of data are in the right, and tail is in the left, right? So in that case, actually, we can just infer that the data is negatively skewed in this case because tail is in the left, in the negative side. And again, for the temperature, we already calculated that this mean Q1, Q2, Q3 act as 51, 69, 76, 81, 86. Right, okay, yeah, 69, okay. Yes, so in that case, your box plot should be from 51 to 86, but here 69 is actually almost in the middle, and 76 in here, and 81 is here. So again, similarly, you can see that it's a little bit negatively skewed. So these are the box plot of each examples. Okay. Do you have any question on drawing box plot? Okay, one question. Pardon, could you? Oh, in that case, it is skewed left because skewedness is determined by the tails, right? But so if you just draw it as a histogram, and you can see that actually histograms are much more in here, and this side is very small, right? So in that case, tail is in the left side, so it is skewed left. Right. Actually, that's what I had mistake in the last time, so I just figured out. Yeah. So these are skewed left. And do you have any other question on drawing box plot or anything else? Oh, scroll up the reader. Okay, yeah. Is it good, Morgan, or do you want to see the previous page? Okay, great. So first reason we use the 5-number summary is that it is a good inference for finding the skewedness of your data. And second one is that it gives us some criterion to determine whether an outlier or not, right? So in the previous examples, we just figure out outlier by my eyes, right? We just see it and say that, oh, it's a little bit, far away from other data, then it is outlier, but there is no, strict criterion for how far your data is, right? So there may be some, some not clear cases can happen, but if you use boxplot, then you can give a definition of outlier as a data value x such that which is less than this or this number. So think about what this number instead of remembering this. So you can see that this IQR is just range between Q3 and Q1, right? So this distance is IQR, right? And Q1 minus IQR 1.5 IQR means that actually you can just multiply this with 1.5 and put it in here, right? So maybe this point, if we say this is the 1.5 times IQR, then this is the Q1 minus 1.5 IQR, right? And likewise, Q3 plus 1.5 plus IQR is maybe this kind of amount, right? And add on this Q3. So this is Q3 plus 1.5 IQR, right? So what we want to do is just figure out how many data are in this side or this side, right? And we call it those data in this blue circle as an outlier, right? So that's the meaning of this definition. So according to this definition, if you just calculate this 1.5 times IQR in exam grade, then first of all, we know that IQR on exam grade is 18.5. So IQR is 18.5 in the exam grade case, and Q1 is 77, and Q3 is 95.5. So Madeline questions, are those two greater signs in the parenthesis and then on R? Could you explain your question again?
Right here where it says Q1 minus 1.5 IQR, and then is it greater than
Ah,
right there?
you mean this, right?
Yes.
Okay, thank you very much. Yeah. So yes, yeah, this one. So X should be outside of the right part or left side of the right part. Yes, I had a mistake. Thank you very much, Madeline and Alexandra. Okay, so here Q1 minus 1.5 times IQR is 27.75. I already calculated it using calculator. So Q1 minus 1.5 times IQR is actually 49.25, and Q3 plus 1.5 times IQR is 127.25. So in this graph, this should be 49.25, and this should be 123.25 exactly. Right. Yeah. So again, you can see that 32 is strictly less than this 49, right? And all other data, especially include 100 is the max, but max is less than 123. So there are already outliers in this data is 32, right? Is outlier since 32 is less than Q1 minus 1.5 times IQR. All right. Okay. Does it make sense? Or do you have any question? So usually when you figure out your outlier, then yeah, honestly, as you can see in my previous mistake, I also didn't remember the exact definition of outlier, but I only remember this picture, right? So if you have box plot, then you can put your 1.5 times IQR on the reps. So it's like a kind of showing your hand in here. And so my distance between this arm and this arm is just IQR, and this 1.5 times IQR is just flip your wings, right? Then any data excluded in this range is outlier, right? Then you can remember it much more easier than just remembering the exact equation, right? So, okay. Do you have any question on this? Okay, then let's deal with the other example. So CDC reports that the number of new AIDS cases per year from 1990 to 204 in Iowa is these numbers, right? So we need to show this data in the box plot with Roberts, and are there any outliers? So that's our question. So now these numbers are not, ordered, right? So first we need to order this number, and from, you can see that actually this number can be ordered as 60, 69, 75, 75 again, 76, 76, 78, 79, 80, 97, 104, and 104, 110, 108, and 156. And I promise you that in the exam, I will do not give you such many numbers you need to put in the number order, right? Because it's just tedious job, right? So I just want to avoid this in the exam. So don't worry too much about this ordering. So if you have this number, then there are 15 numbers here, right? So these are 15 data. So in that case, first of all, our mean is 60. Oh, I write down it here. And our max is 156. And first of all, our median is just seventh number. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so, oh no, eighth number. So in here, median is 79. Because 50 plus 1 over 2 is 8. So this is the eighth data. Then our Q1 is just median of first half. And here first half has 7 data. So our median is in the middle, which is 75, right? And Q3 is the median of the last half. And again, you can see that 104 is in the middle of the last half. So it's just 104. And to show it in the box plot, then what you can have is from 60 to 156. And 79 is definitely close to 60. So you can put just 79 here and 75 in here and 104 here to draw a box plot, right? And to figure out the outlier, first of all, we need to find in IQR, which is 104 minus 75, which is 29. And 1.5 times IQR is 1.5 times 29, which is 43.5 from the calculator. Yeah. So Q1 minus 43.5 is 31.5. And Q3 plus 43.5 is 147.5. So if you just throw those numbers in your box plot, then 147.5 should be here. But 31.5 should be here, right? Which is not even in the range of your box plot. So definitely your outlier only occurs at this part, right? Because that's below the 60, there are no data, right? So to figure out your data, then the only data, only observation which is greater than 147.5 is 156, right? So from this, 156 is outlier since it is greater than Q3 plus 43.5, right? Okay, do you have any question on this example? Good, so yeah, as you can see, if you just figure out the box plot, then you can find out the outliers and skewness. And again, in this case, tail is in the right-hand side, so it is rightly skewed, right? So, skewed rightly, okay. Yeah. Okay, so another data case in here is that, again, there's a new Lyme disease cases per year. And you can see that actually, first of all, we need to order this one to draw a box plot. And here are, first of all, if you just ordering this, and what you can get is these numbers: 24, 27, 33, 34, 49, 54, 65, 72, and 88, right? So here, the maximum is 88 and minimum is 8. And there are, again, how many data are here? So, oh, there are 16 data, right? So 16 data are here. So you need to figure out the eighth data, which is here, and ninth data in here, and your median is in between them. So it is 24 plus 27 over 2, which is 25.5. That's your median, and again, that's your Q2. And in the first half of your data is 8 data. So your Q1 is median of your first half, which is 16.5. And Q3 is the median of last half of data. So your Q3 is 49 plus 54 over 2, which is 51.5. So from this, you can do your box plot from 8 to 88, and Q1 is 16.5, and Q2 is 25.5, and Q3 is 51.5. And to figure out the outlier, you need to find IQR again. So it is 51.5 minus 16.5, which is 35. And if you just multiply 1.5 on your IQR, then it is 52.5. And Q1 minus this number is 16.5 minus 52.5, which is negative 36, but there are no data in the negative 36, less than negative 36. And Q3 plus 1.5 times IQR is 51.5 plus 52.5, which is 104. But again, the max is 88, which is less than 104. So there are no outliers, right? Or you can see it by drawing the Dijon S in here. And yeah, and your range is inside of your, from Q1 minus 1.5 IQR from to Q3 plus 1.5 times IQR, right? So there are no outliers. So as you can see, it is a little bit tedious, but it's very simple to figure out whether your graphs are skewed or not skewed, or whether your graphs have outlier or not, right? So that's why we teach this one first. Do you have any question on this? Good. Okay, then we can deal with the last one. So there are 6 numbers of examples. So we have some 6 numbers, and its mean is 5. Oh, sorry. Max is 19, and mode is 17, and this is median. is 16. And we want to find the possible data for these regions, right? So it is also very important problem in the statistics that if you have some summary of your data, then can you recover your original data from your summary? That's not the easy question, but in this case, we can do it because we know that there are 6 numbers. And one of the numbers should be 5, right? Because 5 is the minimum. And one of the numbers should be 19 because 19 is the maximum. So we need to figure out all 4 numbers between 5 to 19, right? And one thing we know is that this median is, say this one is x2, x3, x4, and x5. And 16 is x3 plus x to the 4 over 2, right? So this means that x4 is greater than 16, right? Because 16 is in between here, right? Does it make sense? And also we know that mode is 17, so we know that 17 occurs at least twice, right? Otherwise, it is definitely not a mode, right? So 17 is definitely greater than 16 and at least occur twice. So we can put 17 twice in the x to the 4 and x to the 5, right? Does it make sense? I think that this is the difficult part, so please let me know if you are not clear. Is it clear? Okay, great. So we know the 17 to 17 are in the last half part because 17 occurs at least twice to be a mode. And also 17 is greater than your median. So it means that these 17 should be in the right side of your median. And again, we know that here x to the 4 is 17. So 16 is equal to x3 plus 17 over 2. So by multiplying 2 both sides, you can get 32 is equal to x3 plus 17. So x3 is 32 minus 17, and which is 15, right? So x3 should be 15, right? So what I did is, we know that median is calculated by this equation, right? And from our previous argument, we know that x to the 4 is 17. So I just put x to the 4 in as a 17 in this equation and solve it for x3 to get this 15, right? And lastly, x2 cannot determine, but what we can say is that x2 should be from 5 to 15, but x2 cannot be 5 and x2 cannot be 15 because if x2 is one of those values, then our mode of this number should contain 5 or 15 as a mode, right? But since our mode is only 1, so x2 cannot be 15 or 5, but it is in between some number, right? So x2 can be 6, 7, whatever to 14, right? So these are the best recovery from the given statistics, right? Okay, do you have any question on this example? I know that this requires a little bit, sense for math, but yeah, but if you understand this, then I think that you're pretty clear that you understand every material we did read today. So please review this example. And if you have any question, please let me know. And let's call it a day. Thank you very much for listening. And see you next time. Okay. Save. The homework includes things about the probability. Will the homework extended? You mean Lainey? You mean chapter 5, or is chapter 5 includes the probability? Yeah. So it will be dealt with in the next time. So and also it is already extended to this Saturday. So I think it is enough time for you to serve.
Okay, I thought it was due Wednesday. So
No, not Wednesday. I already extended to Saturday, so you can do it.
okay, thank you.
Thank you. Okay, and Hannah, going back to on the previous exam. No outlier in the number. Okay, I share the screen again. Give me a second. Okay, take care. So yeah, I will share the screen. So going back on the previous example, how do you know that there is no outlier with the number negative 36 and negative 140? Because you know that we know that actually all data in between the all data are in between this 8 to 88, right? So 8 is the mean and 88 is the max. So if the data, and we know that this minus 36 is less than our mean and 104 is greater than our max. So that's why I conclude that there are no data in between minus 30, excluded in the intervals between minus 36 to 104. Does it make sense, Hannah? Great, okay. Okay, do you have any question?
Yes, I have a question.
Okay.
I emailed you about it earlier. So on this one,
Yes.
and you said to like take this sequence of points right here and add a to the end.
So add a to the in the first. So what I mean is that so in this program.
Oh, okay. I figured out the question. It said a Euler path or a Euler circuit. I thought it was just a circuit.
Yeah.
So that's why I was confused.
Okay. Yeah. No problem. Pardon?
What day are you gonna release the answer key to the test?
Answer key of the test. Yeah. So first of all, I will give you a MakerVision today for some students. But so if it is going well, then I will post it in tonight. But if it is not going well, then we will wait a little bit more time. Okay. Okay. Thank you. Have a good day. Okay. Is there any question? The people in the Zoom? Then I will end this. So please let me know if you have any question by email, right? Okay. Have a great day.